Hi, Phantom here. Today I would like to demonstrate you some kind of device I just developed. During my experiments I find a result of experiments. It very depends on the quality of equipment. And some equipment you cannot buy in market. Now I developed three-phase pulse generation system. If you watch my previous video, you can saw I developed one, but that system support only one output channel and was synchronized of 50 Hz signal. Now I need system able to work in the tenth and hundredths of kilohertz. Let's see what's done. Let's see working of my device as example of one channel only first. You can see on top oscilloscope. Every channel of our device produce the pulse sequence. This sequence have two main parameters. First is just a delay of the front of the output signals after the front of the synchronized pulse. It means this is distance between age of the synchro pulse to the start of the output signal. First parameter, this is delay. How age of the output signal delay after age of the synchro signal. We can shift it. We're shifting our pulse freely on the period of the synchro pulse. Minimum step of changes is 11 nanoseconds. Maximum quantity of steps without scaling is 65,000 steps. If we need delay more than 11 nanoseconds multiplied by 65,000, automatically step increasing by 2, 3 or 4 and so on. Second parameter of every channel is duration of the output signal. It's also independently can adjust. You can see that. I just don't touch delay and change the duration. All the parameters is exactly same as delay parameters. It means step 11 nanoseconds, maximum quantity of the steps 65,000. Both of these parameters, delay and duration, can change independently in every channel. This is I show you independent adjustment, but sometimes you need dependency between these two parameters because it's quite difficult maybe to change three parameters separately, you know, and sometimes you need to link these three parameters and after that change only one and the rest two supposed to follow. Let me show you. Let's put pulses, three pulses, first pulse on top and a second channel and third channel on bottom oscilloscope. Just to put it by some sequence to the period of the synchro signal. Then we make link between these three signals. So in my generator have two kinds of links. Links of delay and link of duration. This is two independent settings. You can choose only delay link or only duration link or both of it. It's up to you. And also these settings independent of each channel. So you can choose many combinations. Now we link up all the parameters, duration and delay for all of three channels to show you how it works. we're changing settings of the first channel. You see, is delay, we're changing delay. You see, second channel and third channel, just a follow-up. It's just a changing in same way, in same value. Now, we are going to change duration in first channel. You see, we're changing first channel duration, and duration in second and third channel is changing too. So all our three channels is linking. One more mode I would like to demonstrate you. But before I started, I would like to say about two main parts of my system. That part I show you, this is output part. It's just to produce the three-phase signals. And first part is just a synchronization. It means this part generates synchro signal. There is two main sources. First source is internal DDS synthesizer. It can be controlled from same phase panel. It can produce signals from 1 Hz to the 500 kilohertz. It's limited now. This step of 1 Hz. Why I limited 500 kilohertz? Because, you know, minimum step of adjustment is 11 nanoseconds, and then higher frequency of your pulse generator, I mean synchro generator, then less steps you can make. And 500 megahertz, this is just a nice compromise between, you know, maximum frequency and quantity of the steps. So now we also can connect to our system to external source of synchronization. It's just connected by this connector. But that source, external source, have to produce the TTL compatible signal. In many applications, you have some kind of sensors like Hall sensors, or maybe some inductor sensor or whatever. It's produced just analog signals. It cannot be directly linked to my generators. So we need to produce one more device to convert the analog signals to the digital one after connection. This device not developed yet. So it means now I just to show you internal synchronization from DDS source, internal DDS source. Now we switch off all links, so now all links is disabled. Now we change in DDS signal, synchro signal frequency. You can see all the output pulse is just standing in absolute position because it's independent. I mean, we're not linked to anything. It's just an absolutely settled position there. But sometimes we need synchronized changing of parameters of the pulses, output pulses, to the period of the synchro pulse. Like three-phase generator, maybe when we change frequency, you know, we need all output parameters be dependent of the pulse period. I mean, synchro pulse period. So now I just recall from the EEPROM presetted the system is three-phase generator settings. So you see first channel finish, second channel up, second channel finish, third channel up. So this is three-phase generator standard setting. So now a link is off. Now we're changing frequency of the synchro generator, DDS. So you see, we change the frequency, but all pulses standing in absolute position. Sometimes you need it, but sometimes not, because in this situation, relative position between output pulses and synchro pulse will be changed, because synchro pulse change, but output signal not. Now we make link to DDS source. This is second way of my work of my generator. This is linked to DDS source. It means all output signals now will be linked to the period of the DDS synthesizer pulse. So you see, if I decrease or increase it, it will accordingly also decrease or increase. You can see that, 1 second. Yes, you see, we're changing the frequency of DDS source, and relative parameters, relative delay and relative duration of pulses, output pulses, changing synchronously to the input DDS source signal. For example, this one you can use when you just define some kind of resonance or whatever. Now we can see what's the inside of my device. I demonstrate the main part of my device. It's actually very simple. Main core is just a CPU board. Is a STM32 board, STM32 CPU, and plus oscillator, plus connectors. Nothing special inside. I have some kind of board, cross board. Unfortunately, I use wires to connect it, and this is because, you see some kind of artifacts on the signal. It's very small, it's not dependent of the work, but if make normal PCB with layer of the ground, I think this kind of small things will disappear. And this is TFT screen with touch screen function. So this is three main parts of my system. My device can be managed by two ways. First, two encoders. By these two encoders, you can totally control all the parameters. But additionally to that, we have touchscreen functionality. So you can use up to you touchscreen plus encoders or just encoders. About connectors, we have three output connectors, and one separate output connectors for the DDS source and one connector input for the external signal. Now this two is linked. I mean, output source for DDS connect to the input source of the synchro signal of 3 channels. Now I would like to show you one kind of demo program where parameters changing automatically by CPU to see the full range of the changing. First step, we just change delay in first channel. You see, look to the first channel, to that. We just change delay of the pulse from the synchro signal to the start of the pulse. We're changing only delay. Duration is constant. Next step, we just change duration. Delay is constant, but duration we are changing. You see, only duration changing is in one channel. Of course, we can make it in 2 or 3 channels. Is independent. Now, next step, we are going to change both parameters, delay and duration, both in same time, synchronously. So you see, we change the delay of the front on the edge and duration of the signal. And now, most funny part, we're going to change all 6 parameters. I mean, 2 parameters for each channel is same time. You can see that. It's just a little funny, really. Below oscilloscope, I don't know why, it's just when changing fast is showing like this way, but you can see this just impressive picture. I think it's enough for demonstration. Now, in the last step, I would like to show you the screen, main screen of the system. Let me download back main software, because this is just a demo software, so I download back main running software. One second, please. Okay, here we are. This is screen of our device. So in the right side, you can see the 3 channels. So in each channel, top row, this is delay in nanoseconds. And second row, this is duration in nanoseconds. Step, as I said before, 11 nanoseconds. You can change, and you can change position, you can change value, wherever. This is I'm changing delay, and before that I changed duration. So if not use touch screen, we can use encoder to change the object we are working with. A little bit not easy to hold camera and press, sorry. Okay, this is synchro pulse, you know, this is DDS source. We can change it also, you know. And below you can see settings. We can we can change the delay lock separately, you know, for each channel, duration lock, and each one have three possible position: off, link, and DDS. So off is no use. DDS is linked to the synchro. This is EEPROM. We can read 5 memory cells or write 5 memory cells, all the settings. Below, this is display on off. This is technological field. Later I will delete it. I think it's all. Thank you very much for your attention. Thank you. Bye-bye.